Roper. She's associate professor. And sorry, ma'am, I don't have your full introduction with me.
Okay, not an issue, not an issue. And whatever you know, you can tell. It's okay.
Yes,
I mean,
yes,
normally
ma'am.
we do. Yeah.
So uh, she's actively working in the field of rehabilitation robotics and wearable robotics, exoskeleton robotics, and other robotics areas also. And we really thankful to her that she quickly accept our invitation, and she is very quick in replying also. Thank you so much, ma'am. Uh, uh,
Wow.
we really
Yeah.
appreciate it. And your talk is going to be really beneficial to our participants, including me, because I'm also a new in this field, and I want to do some work. Although we have started, me with my colleague Dr. Anupam Kumar, we have started to develop a haptic glove in Triple IT Kota, but we will take some help from you also. So this
Sure.
is needless to say that Madam has published a number of research articles in the journals of international repute, and she is also successfully completed and carrying on uh, research projects funded by DST and other government agencies. And my request to all the participants, please pay attention uh, for next 1 or 1.5 hours, and make and so my request to all the participants that please make this session interactive, ask questions so that your doubt will be cleared by her. So with this brief introduction, I request to Dr. Ekta Singla to please carry.
Okay, thank you, Dr. Amit. It's sometimes not the contents of the introduction, but yes, you have recognized that we try to, be faster in our responses. So that itself is a nice remarks for me because, such kind of things, if get recognized, that means people notice your work. But in totality, thank you very much for your first of all, for arranging such kind of platforms because that help to share our work, and secondly for the invitation. And I accepted particularly because in wearable robotics I also started like kind of 3 to 4 years back. Otherwise, being a mechanical engineer, my major expertise is all into optimal designs and optimization, which I'll be, I think, a part of my you'll see that the way I design my presentation, there itself people will get more introduction about our work, and that will help, like whatever we are missing about introduction, I think that will be covered in my lecture itself. So thank you. And now I share my screen, and the WebEx I'm less used to, but I think it will be all right. Just let me know if it is, 1 second, it is being shared. Okay, so is the presentable screen, not yet, 1 second. Is
Yes,
my
ma'am.
screen?
Yes, it is visible.
And it is in the presentable mode.
Yes, ma'am.
Okay. Right. Somebody saying anything? Okay. Yes, I also join hands with the Dr. Amit to request all to keep the mics off. It happens, sometimes I do not know except my screen. I'm not able to see now anything else. And sometimes if somebody has any question or any voice comes in between, then we always feel that it is probably for me, right? So it will be better if you please pay attention to your mics. Thank you very much. So here I start, and your topic is about wearable robotics, and one portion which will come from me, and I promise that this 1.5 hours which you will spend with me, you will have some takeaway for you. Not everyone, sometimes I understand today our audience is all from different disciplines, different streams, And that is the very beauty of robotics, and in fact, not of robotics. These days, almost all the directions are very interdisciplinary, right? And that is the, but only thing is, yes, we keep patience for the different directions. For example, sensors and control guys, if they are here, right? I'll be presenting from the mechanical perspective, like my mechanisms, etc. And therefore, before going into this wearable robotics, in which I'll be introducing about how it is helpful, what are the different type of exoskeletons, because I'll be speaking about the exoskeletons more. And before that, just to introduce my work, so that you should see that it's not that I work only for this. The whatever are
Sir,
your,
answer.
whatever are your expertise, right? You can,
மேடம் இருக்காங்க கிளாஸ்ல இருக்காங்களா மேடம்
yes. Was there any point for me? I think the organizers can mute or let me know if there is any remark for me. Right? Okay, let me move forward.
Ma'am, Amit Kumar
Yes.
here.
Yes.
Actually, we are trying to manage the audience also, and we will mute if somebody accidentally unmute.
Yeah, that is okay. My
Yeah.
point is, I always wait because sometimes I think, I always think that probably I'm not audible. Somebody asking me that ye nahi hai na.
Yes,
So
yes,
I'll
yes.
wait for, yeah.
Yes.
If there'll be anything which is missing from my end, I'll wait for only Dr. Amit's remark, so that I should know that if it is for me. If there is any
Yes.
another disturbance, it's all right. Right. So
Fine.
I
Fine.
just wait because sometimes I think there's no point moving further because if it is not audible. Okay, so you will see that majorly I work in optimal designs. That means in all my directions, you will find that may it be robotics in the area of industrial robotics or medical or defense, mainly what your expertise are, you start from there. Right, sometimes people see that okay, as if this is a new direction. No, it is just an application, and my expertise was related to optimization techniques, both classical and evolutionary, and I have utilized them in mechanisms, right? And for example, the first long back with some association in Technical University Berlin, we started with an exoskeleton. This is my first work, I remember, in 2005 when I got to know what are exoskeletons. But after that, for a long time, I had not worked in exoskeletons. Rather, my major area was related to redundant robots, optimal designs of modular robots for industrial areas, for cluttered environments. Right. This is also some work in association with Institute in Paris, Institute the Systems and Intelligent Robotics. And then unconventional parameters. This is in the last 1 decade. One of the major areas of my working is modular robots, and that means the modularity is being utilized, right, so that we can give customized robots. Like there can be a development of a modular library, and I'll also talk about that in my present lecture. But this was the library which we have developed. 2 versions are ready for industrial, for kind of maintenance and service robots, etc. So you'll notice that whatever I speak, my expertise are related to task-based designs and optimal synthesis and for example, collision avoidance, cluttered environments, unconventional parameters, and reconfigurability, right? And or you can say modularity. And these are some of the pictures from my other works. As I said, one of my major areas in which I'm working in the last 1 decade is related to modular robots. And those who are into robotic arms, they can understand that there are various configurations with which we work. Right now, if you purchase or if you procure a configuration for a particular type of task, right, once, then it will not be very cost effective if the work is non-repetitive, if the work is just for maintenance, and you cannot purchase one robot or arrange one robotic system for any new type of robot for application. So therefore, we are working on modular designs which can change their configuration. So this is just some glimpse of some other works. Moir is my lab, which I've mentioned here. It is actually the modular and intelligent robotics lab in IIT Roper. And you will notice that this is the kind of library. This is actually Moir. We call it as Mark II. Mark I was earlier prepared. Now it is little more advanced. And now, next we have got a project for Mark 3, which will be for the application and medical systems. But this was not for application. This is majorly, you will find that for as a laboratory concept, that how this library can be used for different configurations and what is the meaning. That I'm not making a part of today's lecture, but this you will notice that how this new concept has taken its journey. And if you want planar robots, if you want, say, a twist, a wrist, this is a spherical system is being developed. Similarly, some another spatial configuration, right? Different types of configurations can be developed. So this was all either through simulations or through proof of concept given through the prototype which I showed you, right? That was developed in my lab in the last half a decade. And now let us start with exoskeletons, because this was just to let you know that it's not about the wearable robots, but whatever robotic systems or applications we get, we try to implement our expertise in that. If we now share with you, in this lecture, my lecture will have two parts. I'll just give a 2 to 3 minutes break in between because it was longer. If it is not required, it is up to you. And what we'll do is, like, mainly we'll be talking about what are just to introduce you through this glimpse some of the reported works in exoskeletons. So what are exoskeletons, and then what are the design challenges in that, and how that will be useful, what are the different types of works we have done in this area, right? There are different types of wearable robotics. I'm talking about exoskeletons today. And you will notice that even long back, kind of 2 decades back itself, there had been work in which people were trying to help the disabled or people who are needy old age, right? So everything starts from, say, this was cable driven. You can understand that these cables will be helpful by pressing it is all mechanical help. The manual energy will go down and it will help to lift the person. Its hands, the two hands can lift, right? Then the coordination of this particular legs and the hands is all about the mechanism design. So how many degrees of freedom, what is the category, what are the how it will be done, like actuations, will it be power actuated? So this is actually cable driven. So this way I'll show you some another examples through this reported works. This is not mine, but how people are trying to develop, right, in the last 2 decades, or last particularly 1.5 like decade. What are the possible directions in which people have worked? And this is Rex. It is 4 degrees of freedom, and you will notice that is basically spring driven, that is gravity compensation. So those who are into mechanical engineering, they understand that which mechanism is being used, because my work is mainly into mechanisms, and how this was utilized just for it. It doesn't have any actuator, it doesn't have any controller. In fact, it is mainly based upon the spring action, that how you will be able to support through the spring action. So this is passive mechanism. Similarly, one more from 2003, degrees of freedom were increasing, passive joints were 2, right? So active, if there is a mention of active and passive, that means this is active are actually the degrees of freedom or the joints which are actuated, and passive is which are kept, which can move but which cannot, which will not have any actuator with them. So this way, these are the different throughout, like in the beginning of the last 1 decade, how people had started working in different labs, right? The reported works from the research groups. And similarly, this is the training regs for rehabilitation purposes. Again, the degrees of freedom were increasing, and now they were giving for example, as sensors had been started being used a part of it. So you can have the audio feedback, visual feedback, right? So all these things were mainly used for analysis and training. And counterbalancing, gravity balancing, compensations was a bigger part in exoskeletons using passive joints. Then people had also worked for different types of mechanisms, right? That how to design the mechanism so that it should be best compatible with the arm, right? And those who are into exoskeletons or even such kind of services, and even otherwise, if you are into biomechanics, you understand that our arm has not only 6 degrees of freedom, it has quite a good number of our arms, or our limbs, or in fact our entire body has very, uh, it has very good flexibility. So you cannot really define by 4 or 5 degrees of freedom, but still majorly our arm, right, the upper limbs, each arm is defined majorly by 6 degrees of freedom, or sometimes 7, right? So for example, for shoulders, many reported tasks are used for 3 degrees of freedom, but sometimes people use even the rest two which are at the shoulder, that is 5. So that depends. People were trying to make equivalent to our arm only then the external skeleton, because if now I show you through this introduction what is the meaning of exoskeleton, it is actually the external skeleton which is being connected to the body, right? And normally we are talking about human bodies, right? And for different objectives, people have worked and given some new types of arms. So this was mainly to introduce to you what are the different objectives. People were working for minimizing the singularities or maximizing the power to weight ratio. As I said, I am a person from optimization. We try to see that what is the major objective for which you need to design, right? You cannot fulfill every criteria. You need to see what you want to bring to. Do you want to minimize the cost or maximize the or minimize the power being used, right? Sometimes they are related, and sometimes you will get conflicting objectives. And so this you'll find all the necessary requirements. For example, people had been working for maximizing the manipulability. That is, what is manipulability? In which the way your arm has enough of flexibility, you can do the same thing. If I'm in front of you, we can actually demonstrate our arm, saying that you can always notice that if you just hold your hand at one place, right, then you can still move your rest of the arm. That is that means even to reach a particular location, your hand and particular orientation, you can have infinite many ways of reaching there. That is the beauty of the flexibility or extra degrees of freedom we have. So this is what you would like to achieve. But if you want to wear something on the hand, sometimes it constrains your motion. So rather than helping a person, the exoskeletons which are being worn, that they will actually create hindrance, that will actually lead to some harm or some kind of hurt to the person. So everything, one thing which from here I would like to mention is that if we are working with wearable such kind of mechanisms or wearable robotics, one of the major key which we have to keep in mind, or in fact it is related to any medical device, and key is that how compatible it is, how safe it is to the human skin, to the human body, any part of it, right? So you cannot say that this was for the help of the person. Rather, it is important that it should not be hurting. Rather, it should not be other way around, just because your controller was not working correctly or you have not designed regarding. That is why the existence of ergonomics, the medical support, everything is important in such kind of work. So that is why whenever you are starting in such kind of wearable devices, that means you should have in your team one or two associated doctors or some medical teams. You need to be associated with them. This is the first key, right? Okay, so these are different, I would say that, examples, and you'll find that from different examples, we have got some idea. That was just for your glimpse, right? That, okay, what are the other works which people have done in last 1 decade majorly? And from there, these were the design challenges we had actually worked with. That's why I'm reporting those. And one second. So, for example, there can be different. Now, according to your expertise, you can always look for that what you would like to work with. There is enough directions related to sensors, controllers, majorly actuators, right? You need to have some lighter but still very accurate actuators. And more importantly, you need to have materials guys, material people. They'll have enough work in biomaterials or particularly compatibility with the human arm and making it lighter, etc. So all these characteristics from different perspectives, everybody's, I would say, contribution through your expertise will be helpful. What I work, as I said, in modular robots, I work for minimizing or maximizing some specific criteria. So these are a few criteria for which we had worked in the last 3 to 4 years. As I said, I got 2 projects in this direction. One is from DST, that is an international project. I'll talk about it, right? And second is the DRDO. Yeah. So what are powered exoskeletons? Mainly, I say either you have some passive for compensations, etc. But powered is in which you are giving some external actuation. It's not that only your muscles and the spring action will work. It will be actually based upon some external actuators. And normally here we are talking about electrical actuators. No, right? You will hardly use any pneumatic or hydraulic in these cases. And different mechanisms. For example, this is a compliant structure. Why I'm showing these things? Because being a mechanical engineer, I know that how important it is to design the correct mechanism or correct structure which will be helpful. So this is the new directions. I'm just showing these glimpses that how people are trying to develop different things, may it be for the powered arm exoskeleton, legs, or sometimes hands and fingers, right? So this is these, some of the works are actually from the Indian scientists, right? I normally prefer to see what all groups are working in this. Now here I'm just showing you that if you are working in any such mechanism, what we do mean by optimal design. Now I'm taking my first objective, and this is, for example, here I know that I'm working for a particular, say, finger or a particular legs movement. So the motion, everything you get from the gait, for example, you get to know that from the gait library you get some kind of uh, exactly for the proper human data, human motion data. But what you will do is say this is some points you want to achieve. So what is the meaning of customized designs or the task-based designs which I work with? It is all that if I know that which particular this configuration I'm trying to use, say it can be any configuration. So the first question comes for us is which configuration is best to suitable for a particular task, right? The selection of a particular type of robotic system. The ones which are on the screen, they are actually very randomly generated, because one of my work in I think 2012 person has started. It was a PhD student, and 2016 to 17 it was closed, and this was all about the randomly generated configurations. They are hybrid in nature, right? You are into robotic systems, you will find that mainly the robotic systems are serial in nature or parallel robotics manipulators, right? So if you have hybrid, that means you have serially connected some linkages which are also some parallelograms or some kind of closed loops, mainly in, say, these are planar mechanisms. So which configuration is best suited for a task, and also how to design it, because you cannot say okay, there should be 5 links like this, 1 link like this, 4 links like this, and now what should be the size of the links, what should be their config sorry, cross sectional area, how it, like both its kinematics, its statics, everything you need to design. So this was just a glimpse of such kind of works from my group, that we do not just, we do random generation, and this random generation I call as morphology design. You need to first see that for a particular task, will it be serial or will it be a parallelogram, sorry, 4 bar with a 4 bar, which configuration will be best suited? And you can understand that if it will be randomly generated, those who are mechanical engineers here, or even otherwise, as a open remark, you can understand that if I give you any model, then it's modeling, it's a randomly generated model. Somebody says that okay, I that how to select that which system will be better, and secondly, how to model it mathematically, because if you want to optimize it, if you want to use in some kind of system, then you need a mathematical model, and how to get the kinematic model, how to get the dynamic model, right, which are important even before controllers to be started. You need to have a model of that particular system. So how to develop the system model? We had done that there was a generalized modeling system that you give me, or any randomly generated this kind of system will have its model will be generated automatically, and then we optimize it for a particular task. Like if you want that it should follow a particular task, that I'll speak about it, right? For example, these are the different no, not this these are the 3 or 4 points you can have from human data. That okay, I'll show you some case studies in which what I'm speaking about that has been utilized. So say WP1, that is all work this point first, second, and third. So if these are your working point and you want this particular system, which is being shown as a 4-bar mechanism, which having a extra one more link, which can rotate here, right? So this is the mechanism. And we have a modular system. I'm not getting into the details of all that, but this is also one of the modular systems. This is one module, this is second, or you can have a 5-bar module. So that is why the first, this loop has 5 degrees of freedom. So if it is 5 degrees, it has its different properties. If it is 4-bar, with it has its own. So how to make models, and then these last end effectors, you want this to be reaching these work locations, for example, or this point you want to reach. This is the meaning of task-based designs. And we actually make a model and try to make any particular model reaching to the required data which we take from the human data, right? For example, now if it is being developed, then the links are settled, and we'll say that this particular configuration, which is actually our S1L2 configuration, first is serial link 1, and then it is actually a L4. Basically, we talk about that the second link is a 4-bar mechanism. So this particular configuration is reaching these 3 points, and this is actually some another criteria which tells about what is the performance of it. So basically we work with how many degrees of freedom, how many loops, where will be the loops location, everything in that particular work, right, is a part of this particular design, that we give the basic framework for that exoskeleton to start with. Once the basic frame is ready, then the designers do the detailing, and of course the people who are into controllers, and of course one of our student, there are separate teams, right, who work with then how to actuate it, how to select an actuator, right? But particularly first thing is about the framework. So this was all framework, and if you show this, if I just give you the overall working strategy, and you can always fit yourself in which direction you are working. So for example, in Wearable, how we work with is, before we design for a particular system, so for example, this was a work, right? This student is just closing, right? It was started in 16, right? And basically it is all that if you take some, certainly we have some EMG sensors, a myometer, right? We give angles of different, you get the geometric information, you get the information from the sensors regarding the muscle strengths, etc. So this is what I talk about, the human data. So once you have the human data ready, right, then from there what you get is that what are the muscle strengths, at what location, and which angle, what was the if there was a weakness or not. From this information you see that okay, at which posture how much strength will be required. That means okay, if the strength is less, right, then that means external help is required if it is weak. And if it is if the person's arm is weak, then how much external torques will be required. So and then at which configuration, sorry, which posture. So both the location as well as the muscle strength data will be first taken, and then after data collection, which also takes some kind of cameras, we study about the different postures, different rehabilitation exercises. I'll talk about this later. And we then see that okay, then there is a selection. I was just talking about configuration selection, and from there how to this is just a selection, but before we actually utilize for a particular arm, we say that these are the designed values. That means at least it's geometrical designs will be done based upon what you want, right? So I'll just, this was just a total glimpse what we do, because it's a work of 3 to 4 5 years, right? And while doing this, we got some of the practical applications. That means some of the works which were required for some projects. and I'll just show you those so that you get the idea, because whatever I was speaking, it's from the research perspective, and sometimes you don't get to know what is exactly the meaning. So this was one of the papers in, I think, 21 we got in mechanical mechanism design. So it is here you will notice that there are examples regarding that. For example, this is the 5-bar, right, linkage, and now this linkage has to be designed for reaching this human data. Say this is the data we had collected, that okay, it has to reach all these locations, right? You want a human arm to reach all these locations. A human arm will reach, for example, it's a fixed shoulder point. You will consider that to be fixed, actually it is not moving. So there were questions that human, where we are connecting it to the human joint, even if that is moving, then what is the effect here? Certainly there'll be effect, right? And as I said, we are assuming it to be fixed. So such kind of analysis we keep doing, that if there is a motion here, then what will be the effect at the end effector here? But first thing is, if our end effector is reaching, what should be these lengths? What should be these 5 lengths, so that with good performance, your last point should reach where you wanted it to be, right? So this is just that, which has been shown, that how it's P2, then next point 4. So if it is reachable to all points, then you will take this frame and try to develop it or design it further for the detailing of the designs, right? And then only somebody will start for the actuator selection or some kind of feedback controller, etc. Another important aspect, because that was related to the customized design, another key you have to work when you are into wearable devices, and that is to avoid any, as I mentioned, any type of, to avoid the misalignments. So misalignment, if I define here, in fact, we have a very recent work where we had shown through the simulations what is misalignment, but I cannot add it here. Many of the things I'm showing you from the reported works of others, because our papers are still in process. So that is why I could not show those exactly those simulations. But misalignment is very straightforward, that in case you have, as I said, the human arm has a particular flexibility, right, at its say at its shoulder, or at its elbow, right, but in this elbow joint. Now, but your exoskeletons, they have just one revolute joint here, right? Because the way we design is that, okay, the exoskeleton has one joint here, one joint here, right? But is it really in alignment with the human motion? Normally not, because you have used some exoskeleton, you have tried to make the axis aligned, but it will not remain aligned. Your human arm does not have a axis which is fixed. In fact, its joints are moving. Its joints are in such a way that they are. So you have to make some compliant structures at your joints, right? So this is a very important direction in which we are also working, and how to avoid the misalignment, right? So this is also another key if somebody wants to understand. So basically, for any type of customized works, as I said, you need to look for what are the parameters which are in your hands, right? How many different parameters you want to work with, and then what are the objectives, because this is how we model our system. We model the customized robotic systems made before in any direction by just answering these two questions. So first is how to determine what are the parameters in your hands, which are your design parameters, right? And secondly, the requirements, that is your objectives, and our objectives are coming from the data which we collect from the human motion, may it be about locations, right? Let me show you some case studies. So here you will find that this particular data is being taken. This, in the beginning, we had just the Kinect sensor, Microsoft Kinect sensor, and from there we took some, say this is some human body, and some of the points it has collected only for the joints, right? And for the joints, we had taken only for the joints which are for the arm, not the rest. And this arm, the person was actually folding the arm, and how the data has been done. Now only the last point, sometimes it is up to you how much data you want to utilize, but in our work normally it is the last point. That is because your exoskeleton also you want to reach here, right? But would you like to align this point also? Would you like to align this joint also? This is up to us. So we normally consider this particular point external to this arm. We have our exoskeleton and we want this to be fixed and this particular point to be followed by the exoskeleton. Now you understand that what data I was talking about, that you will take the actual human data and you'll prefer your robotic system, your exoskeleton system, right, to follow that particular path. Right. So the trajectory which is coming, this is not the 5, only 5 had been shown here, but enough data was being taken. And if we just plot in XY, for example, this is the way it has been folded, right? Now, that means you want to have a human structure. So this was a 4 bar over a 4 bar structure. And data driven synthesis means you want any 5 or 6 or 20 points which you have taken. For example, only 5 has been shown here. And this is actually for a human system. But there were many. So these 5 in the other way around. Now these 5 are shown in the different orientation only, right? So any 5, if you want it to reach 1, 2, 3. So I'm just showing you some. It's not about presentation of a research work, but it is all about that I'm trying to give you all the, and from different perspectives, what kind of works can be in wearable robotics, because this was actually for a human arm, as I said. So this data, if you just want that some particular robotic system should follow this data, okay, you will define your problem with that. So this is actually for a sit to stand mechanism. That means I'll just show you that this data has been taken from a person's hip, that where the particular hip joint is being moving if a person is sitting up, right? From sit to stand motion. So from there, if you take the data and then you want that this particular system to follow it, you know why? I'll just show you some picture first, this video first. This is a very, very simple, crude simulation of the mechanism, that how, if, for example, rather than looking for a simple actuated powered, sit to stand mechanism, say you have the person has some kind of sitting chair, I mean the wheelchair, and it also has the sit to stand help, sit to stand assistance. Then you can say, okay, there can be a arc system, like they can be simply a revolute joint which will help us to get up, right? Rather than that, if you say that no, rather than 1 degree of freedom, this is 2 degrees of freedom, or even if you want to have some single degree of freedom system which will help in a smoother sit to stand trajectory. And how it will be, because the key here is human, that you are following the natural human motion, right? So if we are following, or if we say that emulating the natural human motion, that means it will be more aligned to the human motion and the human will not get any jerk. And if you design like that, so this is all the idea, or you can say the meaning, what I was trying to tell till now regarding the customized design or task-based design, right? So this is data driven, because you have given the data, you have taken the data from the human itself, and then you are developing the robotic system or the mechanism which is following that particular data, right? So if you're this is just a exemplary human person, but basically this is a mechanism. Now if you attach this mechanism at both the sides of your seat of that particular chair, then certainly the chair's basic framework of that particular chair for the sit to stand mechanism in the chair is ready. So this is all about that, how we develop the basic framework. And then once the framework is ready, then the next work is from the designer or the actuator or the person who's into driving it, right? The how to give any sense, any kind of gear system sense, these actuators, right, such kind of combinations, that to give it this particular motion, right? But this is the first for the designer. So for doing this, this is the point which we had taken from the actual human motion. For example, here, in fact, these two slides are coming in the wrong orientation. So this I should keep first. This is actually data driven kinematic senses of this particular mechanism. So this is the data which I was showing you, and this is the human leg. So if it is getting up, right, for example, from here to here, it has taken some particular sit to stand motion. Then from sitting to stand, it is taking 1 second point, third hip joint is moving. And we can take not one, but hundreds of such very refined human motion. And then we try to see that how our exoskeleton or any, this is not exoskeleton, here it is talking about the kinematic senses of any assistive device. So if this is an assistive device, this is again in Journal of Mechanical Engineering Sciences, right? IMechE, the proceedings coming from IMechE Part C. It was published in around like a few days back. Now it is written submitted here, but it has come there. So basically, this is being shown that once we have taken the data, then how it is being utilized to develop the mechanism. Similarly, we have worked for different other mechanisms, and I'll just show you again the glimpse through this picture, which is again crude, simulation. That if you have taken the data for a human arm, see, it is not, this part is not aligned to the elbow. So this is just to show you that this is called as end effector mechanisms, because only the end effector is lifting. You understand, it is similar to if we say that you have holded some person at the shoulder and you have second hand as if you are helping a person. So what you will do is you will hold for the support at the shoulder or at the back, and there you will hold the person's hand, right, to lift it. So if exoskeleton is holding it, right, that means it is rather than exoskeleton they normally say by the name those who have exactly same axis. For example, it's not here, it should be exactly similar elbow. So the definitions are changing. But this is the end effector version, in which it is holding it at the last and then helping to lift like that. But it will do this only if it is being designed to do like that, right? Its kinematic structure should be designed to reach at all the points where it want to reach. So this is what we do. And next is if you'll just take this. Yeah. So here you will notice that this is the work which in fact I did, although this is for the spatial works. This was also related to some kind of synthesis and design versions. But as I will say, 1 second. This is the work I did actually in 2005 when I said that I was in Berlin for some specific job, and there this work I found that they wanted us to work on. The team of my professor at that time, I was PhD student, and we that time I studied a lot about exoskeletons because it was a very new concept, even like what I got to know. And but yes, it was a good work. I wanted to just show you that how any specific mechanism, it's not about planar systems which I was showing you. This is a spherical system and it has 9 degrees of freedom, but 3 are active, rest are passive. And this is the hip joint. So you would like not a new joint here. So if somebody's hip joint is weak, you can actually wear a particular system which has a spherical motion. So by connecting it, say the person has a wearable system, this is the belt it is wearing over the waist and another harnessing in between with the thigh, and this is all the basic frameworks. As I said, it not finally look like this, but yes, some of the active and passive joints will give it a motion which is equivalent to the hip joint motion, because hip joint motion is equivalent to a ball and socket joint. And the spherical motion or spherical mechanism, those who are into mechanical systems, they also understand that they are from the they give you the mechanical systems, but only thing is head constraints, how to design it, where the actuator location should be, what will be the location of the other passive joints. All this becomes the part of the designer's work. So this is what we did in that particular work. And you have to do the model, you need to write the kinematic models, you need to analyze them. So this is all that what people do, right? So if you are in such kind of things, if there are people or students who are into theory of machines, they like some kind of mechanical systems or mechanisms, that means this is the direction for you, and you can always implement it or use it in some application of such kind, right, of assistive devices, of rehabilitation devices, right? And majorly you can utilize your expertise in that. So this is what I wanted to show you. And similarly, one of our another works, because see, all these things are big teams, right? It's not that me or any of my only student is working. We had been given, for example, this was a very different team working with CSIR Chandigarh, who had earlier they were working in, this is around, this is kind of, paper had come very recently, but yeah, 2 or 3 articles we have done together. But this work was kind of in 15-16 again. But you know, this was all, you will see there is a mechanical system. This is an assistive device in which it is expected that it has 2 versions. One is for the master, which will be used by the doctor, and whatever a doctor is doing, the slave part of it will be following it. So it's a master slave system. I cannot show the video again here because it was not the completely my team. And whenever we are working with government organizations, it is important to keep their uh, like whatever understandings are being signed. So here you, but if somebody is interested, it is being there in the papers, right? So you will notice that one of its link was, this is again an assistive device, which is helping a particular, this is a master slave robotic assistance for the I mean the doctors, not only for one type of work, but for any. And you know, our human arm has 7 degrees of freedom. That is why this particular system also has been given 7, so that whatever a particular human arm is expected to do, at least that can be transferred to this particular thing. It's not that it has constraints, because if your arm has 7, that means a human body or a human arm is using its 7 degrees of freedom to work for a particular task, right? But you want this system also to be 7, and for a particular reason, this link was used as parallelogram. So how to model it, what is the kinematic model of this particular system, that was the part of my team. Rest, of course, the tasks were given by some another team partners. And this is again for the same system which is being designed. This is the simulation for that. We also do many of the workspace analysis, right, kinematic analysis. So this is a different journal article in which it was being published, right, that how this 7 degree of freedom system was used for, which was designed for a medical surgery, and how we have done the kinematic modeling of it. So yeah, I hope there is no break required because this was a longer session, but normally, I mean, I try to complete in 1 or 1.5 hours. Just let me know, because otherwise I'll take kind of 15 or 20 more minutes. Is it all right? I'm not getting
Yes,
any.
ma'am.
Yeah, okay, right. So this is because I'm trying to connect things both from the research perspective and the different aspects which are connected to it, and more importantly, what are the types of projects which we have done, so that you can always connect yourself according to your expertise to such things. So APATH is our Indo-UK joint applied, because this is a Newton Baba project which was which we have received in again 17-18, and it was delayed, although it was a 2 years project, but just recently we are closing it because of pandemic. It could not be worked upon much in between. So this is actually again an adaptable device which has both the lower part was had to be done by the UK partners, and the upper arms were to be designed, for the exoskeleton to be designed by the Indian partners. But this was majorly a, you know about GITA, which is a global innovation and technology alliance, which is majorly being used for the industry alliance, and how the industry or the guys can be helpful in association with academia, right? So you can always have projects from from DST GITA. So our partners at that time are mentioned here. Advanced Tech was the Indian industry who was a partner, IIT Robot, and TWI was the UK industry, and Innotech UK is the academic, is the UK academia, right? So this was, I mean to mention that this was a big project. Of course, we cannot show much of their work, but yes, very initial. Like I can tell you that whenever we start with some test rigs, right? How we had seen that, okay, something which we had tried. Now the final versions I've never put as in the demo here yet. Once it will be, the reports will be gone, only then I'll add in my presentation. But yes, the final versions have come out very well, in which we can have an arm exoskeleton. This is just a glimpse of all the works which were being done during the work of this particular project. For example, you should have a back system, which should be enough supporting. You can always use some kind of, as I said, closed loops, or so that it can actually, or passive joints, so that they can support your arm. Where it should be attached at the shoulder, should it come from the back? All these things you design or try to see from the human comfort also, and designing the actuators, doing the path, taking the human data, making the path planning, etc., motion planning, etc. For this was being mentioned for eating, but yes, for any task or rehabilitation task, how to design this particular part, what should be the geometrical features, what should be the other features. So this was all majorly what we do. Again, just because these crude things, normally when students work with us, there are many interns who do come, and some interns work well, and this is all the simulations coming from their works. But what is there in the papers, I do not show much here. I prefer that if you are interested, you can always look at the articles which are connected to such things, right? And you can actually read the articles. But here I normally show the simulations which I collect from the initial works. Yeah, this is important because we had also worked in association with Rehabilitation Center, New Delhi, the national center. Because from there, unless you, as I said, it is important key that you keep in association with, for example, with PGI doctors. Also, this is a rehabilitation center because we were working with them. I met the head of the center in some conference, and then it was very helpful that they were let us know what are all the rehabilitation exercises. So if we are studying the exercises, then based upon the exercise, because normally the rehabilitation is being done by a help, or some say the people who are into this, who are trained to get the rehabilitation exercises done for a weak person, or a person who has just got the some neurological problem or some kind of health issue. So from there, they know how to start, how much to help, which exercise is important. But there you need the expertise, and then they also see that should they really help, or should the person should do himself or herself, right? So these kind of information is being grabbed, and our very recent papers, which are not yet they are into process of publications, we have given this particular work, that how we have studied the data given by rehabilitation exercises and their expertise. And then this was actually, I just showed you, but basically what are the different, I am also using my modular primitives, because not only earlier I showed you the modular library which is developed, that is at a better stage, or for the industrial or maintenance tasks, for the service tasks, right? But now this is mainly we were trying to give similar primitives, or modular links, which can be used for customized designs of the exoskeletons. Because you need, people say we are working with this rehabilitation works, so rehabilitation is required in different age groups, and different not only just age groups, but mainly their heights and their arms, they are all of different sizes, etc. So what can we do about it? That's why we thought that, okay, we should just see what is the task, and accordingly we'll design the modules, and the modules can be 3D printed for a particular customized a mechanism or a customized exoskeleton. So this is all what, because my point is, what I was just showing you here as the overall work, which has been recently completed, right? One of my students, Sakshi Gupta, has worked on it, and there you it is all about that, what are the type, as I said, we had done all the study. So this study was in association with Rehabilitation Center. So these were all the data being collected, human data for the different exercises, right? And you will find that basically using the exercises, we had developed that which modules will be helpful, and then using the modules, how this particular kind of structure will be made. These details are there in our recent papers, which are yet in publication. And this is how we show that our major contribution in that direction will be how to model these things, how to select, and for a particular for a given, say, a human, there is a person with 40 years age, male, and he has its own trajectory, human motion. And then there is another person, because we have done for a particular age group, not that children as well as the old age, not everybody, but for a particular group also there are variations. And if there are variations, at least you take the, you design for a particular person, and accordingly it will be 3D printed, because nowadays technology is increased. You need not to make the links a priori. You should have a modular library in soft version, and then that will be used for constructing or for fabricating a robotic exoskeleton. And then once the exoskeleton is customized for a particular person, that can be fabricated. So this is what we are doing almost in very recently, because I was also telling you how we have evolved towards this direction, right? So for example, this is the configuration. I'm not showing details of it, like how, what all type of modeling we do, because this is associated to very small group of mechanical engineers. And similarly, another configuration, say somebody says I want 5 bar, so different modules are being developed. Similarly, the same modules are being developed in the program or in the code, right? And whenever somebody wants to model it, it will be modeled modular through the modular programming, right? So I think the concept of modularity can be take away today as one of your learnings, but how it can be used in your system, that you can always see. If you are working on controllers also, it is important that how you can code them so that for different applications you can actually use them. Okay, so this is quickly, I'll also talk about my very recent work, which was from DRDO. There it was related to exoskeletons, a leg exoskeleton. I can just show you this glimpse, which was fabricated at DRDO lab Bangalore, and because this was allowed to be shared, right? And but not the details. So what was our job again? It was again that we have an exoskeleton. It was already built based upon some design, but now they wanted our team to first make it a proper model and then analyze it where it is going fine wrong, because they had told us that when they were wearing, they had done it to a very good extent for the soldiers. So it was not really for the health, for the unhealthy. It is actually for the very healthy soldiers, just to help them, for in walking or in different terrains. But at present they had worked only for the plain terrain, and how they, because the entire objective was to reduce their effort, right? So that they should not get tired while walking, right? And similarly, you can always help the soldiers to carry, using the full exoskeleton, you can help them carrying, because this is all you might have studied in the very beginning. These days there are different, I'm not taking the names here, but different robotic systems which are being used for defense, for healthy. And similarly, the robotics, the exoskeletons are being used for healthy workers also. It's not about only rehabilitation systems or for unhealthy or disabled, but also for the say workers, so that if you can afford, if somebody can afford, it can help them to lift double or triple or 5 times the payload which they can otherwise lift through only the manual action, their muscles only. But if they can use the exoskeleton, they can actually work, and differently. So the kinematic model, their analysis, and what are the other types of, because it's not that only single link with single link. You'll understand here it is one actuator here and one actuator here. It was just a 2 degrees of freedom for each leg they had designed. So we have given them why there was a misalignment, because they have told us that they're finding some type of misalignment, jerks, right? So our team was helping in the misalignment. So this is all because I wanted to just tell you what kind of systems we had developed. But yeah, through this 1 hour or approximate, yeah, almost 1 hour, I think I tried to give you all the glimpse. But yes, I would also show you that I am coordinating or chairing the Punch Robotics, which I started in 2012, because all you guys, I am also talking about so much of mechanical things, and many of you may not be associated to only mechanical engineering. They are from different streams, sometimes absolutely different from economics, not even engineer, but everybody is required these days to know each other's directions. But it is important that we should have platforms like today we are meeting. Similarly, This is why we keep organizing workshops or some kind of events at Punch Robotics. You can check this particular www.punchrobotix.com, the particular platform, the web page, and here we keep inviting speakers and we keep giving some kind of latest advanced, say, ROS. ROS is very important, robotics operating system. So it is important that whatever we are doing, it should be utilized, or it should be um, in line with what globally is being expected, right? And in robotics, I always say the next key which should take away, which should be from my side takeaway for you, that if you are getting a chance, maybe you are a faculty member, senior faculty member, or a student, if you are getting a chance to know about and to learn ROS, then it is extremely important. Do join the workshops for ROS, do arrange the workshops for ROS if you are a faculty member, so that your students, they should learn about robot operating system. So this is all what we keep doing. You can always check the news and events here. And sometimes we are not even active for a few months, but sometimes there is. And we do have some many members. If somebody wants to join, they can always write to us, right? So this is all about the interdisciplinary platform which I have developed. But yes, I'm not speaking about much in this lecture, and you can always check through its webpage. So with this, I close here, and I'll keep rest of the time for any discussions, as Amit has mentioned that it should be interactive. I do have many of, you know, we are ready with many slides and many different directions. So if required, I can always talk about some another thing. But I think for today, it was enough takeaway how we have done design challenges. I talked to you. And okay, these are some of the glimpse about the project status or some Punch Robotics. Like these are the members. We have some kind of PR studios. Punch Robotics is PR. And we have humanoid industrial robotic systems, some kind of very sensitive UTM, which is helpful for medical devices, which are smaller in size, etc. And some of the machines which we have bought, so some of the twice. Yes, second thing is, please join the Robotics Society. I don't know how many of you are a part of Robotics Society, but if you are, nice. If you are not, try to join the Robotics Society India, because uh, when you meet then you will find that what are other Indian people, Indian researchers, they are doing, and they can help you rather than only writing or in the conference, writing in the journal articles. You should meet in the national conferences, and it is very good because the Robotics Society, earlier its name was Robotics Society of India. That's why this volume was coming in 17, but 2020, 21, in fact 23 conference, I probably feel that I can announce. I've not started with its webpage, but the Advances in Robotics is the conference which is run by the robotics system, which is organized every second year. I mean, alternate year, biennial, uh, by the Robotics Society. It's Advances in robotics, right? So Advances in Robotics 2021 was in IIT Kanpur, and 19 was in Madras. Now next 23 is being discussed for IIT Roper, and I feel by the time we should be over from this pandemic act, and we should be able to really invite you all and others. And please keep an eye regarding the announcement of AIR. It is Advances in Robotics 2023. I have not written anything about it. I'm sorry yet. I should prepare a slide regarding it now because the time is coming. And it is in IIT Robot, and I wish it will be actually with everybody's presence rather than in hybrid mode. So rather than in online mode, we'll keep it hybrid because hybrid will help us to have more international connect for all of you. So thank you very much. With this, I close, and I stop sharing also. Thank you very much. Any questions?
Yeah. Uh, uh, Thank you so much, ma'am. Participants, if you have any questions, please ask.
There is something in chat.
Okay.
Okay, it's about attendance. Okay, Professor. Okay. It's about your two.
Okay.
Hello, ma'am. Good afternoon.
Yes.
Ma'am, for prediction tasks, how to collect the data from the robotics?
From the robotics or from the human?
Yeah, robotics data.
Okay, that is all related to what the sensors. Certainly, as you know, as we my particular work, it's not that my research work is in sensors, but yes, you use all types of different sensors, may it be starting from encoders to myometer. See, you if it is about human data, mainly in exoskeletons, people are worried about. We have a biometrics complete data kit which has a goniometer, which has a myometer, etc., which helps us to take the human data even while you are taking some of the experiments, right, which helps to give you the torque and the forces at the different muscles. Also, I suggest here that we have some specific softwares, OpenSim and Anybody, I'll write it here, which helps you to give some of the data regarding the human thing. But if you talk about the exoskeleton and the robotic data, that is like any another robotic data. You have the encoders, you have inbuilt actuators which are having all the sensors, right? So in fact, you have gyroscope, right? So you can always talk about these sensors, which are normal robotic sensors. So my expertise is not into that I'll tell you anything which is recently coming, right? Because I'm not into fabrication of all these. But I must say that the softwares which you should take, because somebody is talking about the okay, tendon driven, that I'll come to. Say Anybody is the recent software which we have purchased. It's a commercial software, but it's very important. But it is good that if you are working in that, you can actually use Anybody, because it helps you to do the coupled analysis, both robotic systems and the human system. So it will give you the dynamic analysis very strongly, right? But if you want a open software, then it is OpenSim,
Okay, thank you, ma'am.
right?
OpenSim.
Yeah, OpenSim is open software. You should at least try your hands. It is compatible with SolidWorks, etc. So whatever you are making in SolidWorks, you can simulate through the OpenSim, because there you'll get the human structures. You need not to make yourself.
Thank you, ma'am. Thank you so much.
Okay, Shia. Somebody has asked about how tendon-driven system are in their reliability, ma'am. Yeah, actually, although I have not worked with, but you know, tendon-driven have in this direction of tendon-driven, it is coming up very well. In fact, there are specific conferences only on tendon-driven. That means people are trying to get into it. I know two people in India. You can read their papers. One is even from NIT Jalandhar, Dr. Vaz, Professor Vaz is working in that. And then in IIT Gandhinagar, Professor Vineet is working in that. So you can check their papers or recent works if you want to check about the recent developments, right? So Dr. Vineet from IIT Gandhinagar, you can check, because he works with the not just tendon driven, I mean all these using the ropes, etc. But it is coming out well. You know why? Because you understand, that is why you have asked the question. It is all about the actuation, and if the actuation is it can be controlled through can be okay, you can avoid the actuators, you can avoid the heavy duty, or you know, then it is more compatible with the people. But yes, the recent developments you can check with their papers. Okay, somebody has written, kindly highlight some of the commercial implications of these robotics in human life. Commercial implications in human life. Okay, so maybe you are concerned with, if you ask the question, then I'll just understand how, from which perspective you are looking, you want me to answer. But yes, how I understand is, see, I will say from the Indian perspective, because I remember why I opt for one or two these projects, because when we started, and I have seen in front of me 2 or 3 new companies, I mean just nearby me, they are coming up, you know, because in Indian robotics or Indian exoskeletons or Indian healthy or unhealthy people, it's you get enough of assistance. You, if you say that we get assistance, so people will really not get into very expensive exoskeletons. But nowadays you also understand that you get, pandemic has actually given that particular, our 2020 has given us enough of such applications in which sometimes it is not available everybody's place. And if you can get into cost effective assistance, robotic systems, I mean automatic systems which are cost effective, then at least it can be utilized by a not the individuality, not that you can use it, but as a commercially it can be taken up by some rehabilitation say center or by some small hospitals. They can purchase 5 of them. They can always give to their unhealthy, for example, somebody who has just got released from the got operated. Then rather than coming to the hospital many times, you know how we have seen in pandemic that the hospital visits themselves has become a trouble. So why to make rush there? You can always do the exercises, rehabilitation or some kind of assistance at home for 3 to 4 months, and then you can return the exoskeleton. So this is how I would say it's increasing. It's commercial applications or commercial demands, etc., are increasing even in Indian robotics. But yes, the problem is coming with misalignments and their utility and accuracy. But that is what the designers and their researchers' work is. But yes, commercially they are coming up. That is why people are looking for their 1 or 2 companies in front of me. People have started in exoskeletons. Yeah. Anything else, please? See, even my involvement in wearable is the least in my own expertise, other type of expertise. Yeah. So this is all. I'm also learning like you, but only last half a decade I'm into this research work. Although I'm into robotics for the last kind of 2 decades, but half a decade only in exoskeletons yet. So I'm also learning. Yeah. Okay. Thank you very much. Okay, your voice is a little breaking, Amit. Thank you,
No,
Prajapati. Yeah.
I'm not speaking.
Acha.
Uh,
Okay.
uh,
So yeah.
yeah, it's really a eye-opening session. I totally agree with you.
Okay. Thank you very much. And I'm sure because we also feel that in this 1 hour you give to us or you pay to people like Amit or to ATAL and everybody. And we are thankful to, in fact, all these organizers, starting from AICT and this and any another, I would say, because they help us to give you this 1 hour we can actually share and you get some takeaway. It's not that everything was helpful for you. You can always connect to, and at least if few people started working in robotics, I always say that Indian robotics is coming up in the last half a decade. It's going in a very good direction. But earlier, many of us people like me were unhappy about the Indian robotics. We used to see that we are working, but why there are not much of platforms to share our things. So now it's coming up. You please come into robotics, whatever area you belong to, and it is coming up very well. There are even tell your students there are job facilities also. I mean, job opportunities are increasing in a very fast scale. So this is important, and you should actually encourage your students also to get into robotics. With this, thank you for all the nice remarks. Thank you very much. Bye. From nanotechnology background.
Ma'am, I have one question.
Yes.
Uh, uh, we are working to develop the soft robotic arm,
Okay.
the complete arm, and which material we should take, silicone rubber or something else?
No, actually, one, I should not comment it as it is because every material, if you are talking about rubber, because I'm not into processes, first of all, and then not into materials. I can always, you can please write to me. I can associate you with the people who are into soft robotics, right? For example, you can write to Dr. Prabhat, etc. In fact, I'm also working one of the project I have with them, but I'll not, we cannot exactly, say that for this purpose. It depends at what stage of your analysis you are, what cost you are ready to give with, and then there can be a few materials which are not even available in India, and so basically there are different types, and we can always have such kind of discussions. Amit, this is a very good direction, I would say. Soft robotics is coming out very fast, and some of our people who are into materials, they have come up to work with me in robotics because they had seen the application of materials in robotics, soft robotics. So there are different things, silicon, rubber, or something else. But yes, I think you can write to me. I can connect you to the right expertise in this area.
Okay, ma'am. Many thanks.
Yeah, and
Uh,
it depends if you are at the prototype stage or if you are recommending somebody for the actual processes, etc. You know, so that depends.
So definitely, I will seek help from your side later after
Sure,
this.
sure. You can write to us. Thank you
Yes.
very much. Okay.
Okay. Thank you. So it is really, really very nice session, ma'am. And if other participants would like to ask if they are facing any
It is
problem in their
disconnecting from my side.
okay.